into the cloud. All right. So the agenda for today's meeting. I know that you, Rob, and have been interacting with Gary a bit on some of the rules. I'm sure Gary has some updates. I know Steve sent me an update by email about the TDOA. So I think I would be happy to turn it over to Gary to kind of run the meeting and give us an update as to where we are on the amateur radio side of things, and also maybe hear from Steve Serwin and make that our main, and then kind of set the agenda, figure out what happens over the next few weeks. Because as I said, I really kind of met my goal of getting that proposal put together and getting that submitted. So that's a now. And I think the good thing with that proposal being in is it kind of sets the overarching science goals. So we now have a reference document that we can go back to for why are we doing what we're actually doing. Does that sound good?
Yeah. Yes.
Great. So I'll turn it over to Gary, and Gary, you can run things and I can take notes and such.
Okay, very good. What I'd like to start with is just a minor bit of good news, I guess I would say, is that let me take a look at my email here. I'll share my screen for the heck of it. There we go. I got feedback from Becky at the ARRL regarding their interest in publicizing the SCQP and associated events in both QST, and she also suggested the On the Air magazine, something that we may publish that would give an introduction to citizen science and kind of whet the appetite of potentially some of the newer hands to get involved. But I think that would be a good thing too.
That's wonderful.
Yep. So it looks like the deadlines for those things are in the let's see, what was she saying here, deadline wise? They need material by early July or something like that, which should be no problem. We certainly got plenty of time, and our rules will be finalized and published on the public website by then. So
Gary, this is at WX2R. That's really good news, because I think, as I've mentioned to some of you, I'm on the ARLPR committee, and with Becky on board, that makes it, I think, a really easy lift to be able to get it on our agenda. Okay, so we can work with the PICs, PIOs, and local clubs that are relevant. Okay, that'll really help us get the word out. So that's good news.
I recommend you time it for the September issue, because sometimes the monthly issue of the month you're doing it in gets delayed.
Right. So that makes sense. Yeah, I'd rather be earlier rather than later. I think you're probably right, Dave. So that's a back burner item, but it was good news to have that out of the way. And I think you all recall too that Rich Moses and W2VU from CQ agreed that it would be good to publish some articles as well. So I think we'll be fine there. What I'd like to do is just present an idea I had so far as kind of dividing up the rules a little bit, and then maybe, especially since both Gwen and Rob are here, take a look at some of the details on that, and then turn it over to Steve in a little bit. So let me get into the test site here. So if you recall, we kind of had the rules similar to 2017, where we had the actual two-way QSO party, and the rules and the Whisper event were kind of blended together. And I think the Whisper event is gaining more and more importance and relevance. And so my suggestion is that I would like to peel these out of the QSO party rules and have a separate page for the Whisper. Let's see if I remember where that was at. Sorry. There we go. So what I tried to do is to kind of make the Whisper party portion of it sort of standalone. some of the similar verbiage at the top for joining the mailing list, the dates and times and all that sort of stuff is going to stay the same.
Do you want to put the word Eclipse on top of there? Eclipse Whisper Party?
Yes, and make a note of that. Find my notes. One thing that's important though, probably get out of the way sooner rather than later, is we had, and maybe this was naivete on my part, but I suggested in the last rewrite of the rules that we require people to exchange 6-digit grid squares, both in the QSOs and Whisper and FT8 and all that sort of thing.
Mm-hmm.
And in spending some time operating a little bit of FT8 and
Mhm.
reading about Whisper, of course, they're also all part of the Joe Taylor suite. Is you can only exchange 4-digit grid squares in those modes.
Mm.
The payload, I mean, the FT8 payload is limited, and they figured that there were roughly 31,000 grid squares, 4-digit grid squares on the face of the Earth. So they only allocated 15 bits, rough, which is about
Yeah.
32,000 entries. So 2 to the 15th. So I don't think we can really require people to exchange 6-digit grid squares.
That seems reasonable. Well,
Okay, so
a lot of that, I think a lot of that exchange of exact information isn't necessarily even needed, because so long as people are submitting the log entries and reporting their actual 6-character grid square or lat long in the log submission in like their header file or their soapbox, then we can get the information off of there and match it with the QSOs.
right.
I
So
did
that's
that.
true. So that's
Yeah,
we'll
I
have
did
to
that a lot.
emphasize that.
Yeah, I did that a lot the last time. So I wrote a script where I had like a precedence of which locations I trusted most. So the location I trusted most, if someone sent me a log file that said this is my location, that's the location I used. If I didn't have that information, then I would go to like information that was in the Whisper code, in the Whisper QSO itself. If I didn't have that, then I'd go to QRZ.
Good. Yeah, it would certainly work again in the next couple of years. So okay, so yeah, that's the same thing. Well, like, the other thing I was thinking about too is, for the regular QSO party rule, people be running N1MM or something similar.
Mhm.
You're right. They'll be in the Cabrillo file header. I was thinking for the Whisper party. I mean, I'm not sure if it would apply to the TDOA event or not, but is use some sort of a Google form to accept people's input, because they really don't have logs, so to speak.
Mhm.
And that Google form could obviously require a 6-digit grid square, so I think that would help.
In terms of Whisper, you definitely want to discourage, the 6 digits, because what in Whisper transmissions, when you put in 6 digits of grid, or you have a call sign with a / in it, then the Whisper transmitter transmission goes into a 2 packet mode. It sends back-to-back packets. And consecutive in 2 consecutive 2-minute long transmissions. So if someone stimulates the WSJTX to send such, 6-digit maidenheads or 6-character maidenheads or a call sign with a slash, then you actually get less information, half as much information, really. It would, especially if someone is doing band scanning through the event, I think we'd want to have as many transmissions from any beacon site as possible that to contribute information. And so it would be, if someone is set up to scan 80, 40, 30, 20 on their, on their beacon transmissions, it would be good if they did at minute 0, I'm pick minute 0, 80, minute 2, 40, minute 4, 30, and so on, so that we get as many different frequency samples as possible. And if they, so that's, I would I would debit people for points if they put in those longer grid squares. The other thing is that I believe that the WhisperNet site, when you upload your if you upload a spot with 4 digits, I believe they go and look up if you have an account with WhisperNet, as most Whisper transmitters do. If you have an account in the I think they look it up in your account on whispernet.org. You can put in your 6-digit location, and I think that the WhisperNet may fill in those 2 additional maidenheads if they know what your maidenhead is. So I'd have to check that again, but I think there's several reasons why you want to discourage the longer transmissions.
The other route for WhisperNet, the database, to automatically add the last 2 characters to go from a 4 to a 6 is if the same call sign has even once acted as a receiver and reported with a 6-figure grid.
Oh, really? Well, then maybe that's how that information gets to you. I didn't realize
I think
that
there are those 2 routes, Rob.
Wow. Well, in any case, the one of I think is important is to get as much unique data as possible, and as a result, you want to avoid generating packets that basically are redundant. So.
And that's fine. That makes sense. That's why we need your and Gwen's input. So I can certainly emphasize the 4-digit grid squares through here in the rules somewhere.
Yeah.
I think even for the phone QSOs, like I just think 6-character grids are awkward over phone. You know, we want the QSO, the exchange, to be comfortable for people so they can make a lot of QSOs and enjoy it. And you know, if people are going to be reporting that information over you know, over the log system anyway, why should we duplicate it there and add more tongue twisters?
That's fine. No problem with that. You know best what you need too in the end, and the end result after the so.
Yeah, I mean, as long as people, I think, you know, the people who are participating in the phone SCQP or even on CW, you know, they're likely going to be submitting logs. Why do we need to make the phone or the CW operators, you know, submit, you know, exchange those extra characters when we're going to get that when we're going to get that location information submitted anyway?
Good point. The other thing that I'm trying to learn a little bit here too, Rob, is I've got your suggestions about how to configure the whisper transmitter, where to set the audio frequency, the type of messages, and the transmit percentage of 100%. So does that mean that somebody will transmit a 2-minute cycle and then go right back into transmit immediately thereafter?
Yes. Yeah. I mean, the JTX will, of course, the packet is actually, I think, 108 seconds long or something. It's not a full 112 seconds long. So there's 8 seconds of kind of silence, roughly 8 seconds of silence, most of which is before the top of the 2-minute cycle, and there's I think 1 second after. So the protocol actually leaves a gap where there's no transmissions in theory, you know, where the carrier would go away. You can see it on a waterfall. You can see the carriers as they reach the end of a cycle. All the carriers, almost all of them, except for the people who are out of NTP sync, all the characters, transmit characters, go away. And then you can see them reappear. The new ones appear. I think it's 0.8 of a second or 1 second into the cycle after the top of each 2 minutes. So there's a gap where you're not transmitting. but I mean, most of these are going to be, this isn't a, I think shouldn't be a duty cycle issue for most. I mean, I think most of these transmitters, whisper transmitters, I would expect to be regular transceivers with their output levels just turned down to 5 watts or something like that.
Well, you've also got the crowd like myself who bought a tapper, a hat for a Raspberry Pi.
Yeah.
And
Yeah.
there's not much configuration you can do there, but let's see how that works.
Well, there's U3Ss, there's Zactechs, there's a bunch of devices out there that I'd have to look at the Zactech configuration. I don't remember, but I think in almost all cases you can set them up for 100%, and I don't see any reason not to.
Okay, well, it's pretty easy to word this to suggest as we've done here. Set it to 100% within the limitations of your transmitter. So I
mean, and some we ought to encourage people to spread themselves out. Don't all transmit at 1500 hertz. It's yeah, the decoder can call you out of there, but it'd be better if people were to spread themselves out from the center of the whisper band. So, we might encourage people to come up with some kind of hash table on their call sign or something to figure out a transmit frequency, just so that then everybody isn't stomping on everybody else. I mean, if we're really fortunate and there's hundreds of people turning on their transmitters, it would be good for them to be spread across the 200 hertz of the whisper band rather than bumping at some location within
sure.
some
I can
frequency.
work on emphasizing that a little bit here too.
Yeah.
The other point you made that you and Glenn, I would hope we could, is I just kind of copied this bit about try to keep everything in a 500 meter diameter circle, just because with the way remote stations are, I mean, you could have one person sitting in Tennessee and claim, a gazillion sites, and
yeah,
I don't know if that's a good or a bad thing, but
yeah, I don't know how many sites we'd have where people would be transmitting and receiving simultaneously. But that would be the only reason, if you were trying to do them at the same time, potentially your transmitter could overload your receiver. Obviously, they can't use it. They'd have to be on, in any case, they'd have to be on separate antennas. I don't know that I've ever experienced with that. I think that I've heard people say that if you're even, several hundred feet, so maybe 500 meters is, enough distance between a 5-watt transmitter and a receiver antenna to avoid overload. Of course, it's a function of the receiver's characteristic. I'm thinking mostly of the Kiwis, which have a 14-bit A to D, but I think things like other SDRs have at least everything except an RTL SDR class thing. All the other devices have pretty good dynamic range. But that was the only reason I suggested maybe a wider diameter than 500 meters, is give people, to encourage people who want to transmit and receive at the same time, the opportunity to move their transmitter a little farther away or the receiver a little farther away.
okay, so that brings up another good point is this thing really, this site, the definition of the site really comes from the normal regular QSO party guys, where you don't want to have somebody taking up 50% of a state and having remote stations across a multi-mile area and claiming it was one.
Yeah.
And so one of the things I've been rolling around in my head is the whole whisper thing, and the idea of scoring is very, very difficult. I mean, it's almost impossible to come up, I think, with an algorithm that would please everybody. So I'm not sure if scoring whisper is the right term, or if we do something like this and say in the results, we kind of, here's the results we've got, and we're going to have all this information, and just publish it, and people can kind of self-rank, because you've got people on ESK Report or WhisperNet or maybe Whisper Demon we're trying to encourage, and there's so much variability. I'm just trying to come up with trying to have a hard time coming up with a practical solution.
I agree. I think it's a little hard because the Whisper Demon sites with, like WA2TP has seven antennas and kiwis running simultaneously. So he's gonna pick up everything, every band, every cycle. Well, most of the Whisper sites are going to do that. So I wouldn't want to discourage. I would rather encourage other listeners, I wouldn't want to discourage them. Have the Whisper Demon sites discourage people from listening. And that was one way of doing that. Is suggested itself to me, which is to give people a lot more points for the location of the receiver. As if as I understand it, if that it's desirable for us to have the geographic location of receive sites to be distributed on underneath and either side of the path of the Eclipse, that sites that are near to those locations would, I think, contribute a lot more useful information than ones like WA2TP in New York City, who's so far away that it's not clear how much how useful his spot reports would be. Does that make sense? I mean, you could figure from the receive sites, the reporter's Maidenhead, how it's kilometers from the path of totality would be a multiplier. So if you were within the 80 to 70% a receive site in that band, you would get a multiplier for your reports. And a bigger multiplier if you were between 70 and 80 and so on. But again, I'm suggesting that because I'm guessing that those sites would be more scientifically useful, reception reports from those sites. So Nathaniel, you would be a better person to comment, than I. I'm just suggesting as a way to kind of encourage receive sites that would otherwise might not, do very well.
Yeah, anything we can do to encourage more receive sites is definitely a welcome thing scientifically. I was just thinking as I was listening to this conversation, we do have to really make sure that we're able to keep track of where these different receive sites are, because I'm thinking about how I would write my software to verify locations. And if I just used call signs to verify location, you have a Whisper receive site at one location and a transmit and someone operating on the SCQP with the same call sign from a different location. That's going to be confusing to keep track of where which one's actually located. So somehow we need to be able to keep all of that straight.
Well, the spot reports include the locators for both the transmitter and the receiver. The reporter, as is the term used in the Whisper Demon. So at least you get 4-digit, 4-character Maidenheads for both of them from WhisperNet. And for in the extended spot database, the Whisper Demon reporters, the spot reports include all kinds of additional information about the path length, the direction, of the path direction and length and so on. So, but that information could be calculated for WhisperNet reporters as well. It just isn't done by WhisperNet itself. But so I think it's possible to identify and separate out transmitters and receivers that have the same call sign. I don't think that's a problem. That's
as long as we can keep track of all those locations appropriately, then
yeah.
then more is better.
Well, there's well, and so that'd be my proposal, is put in a multiplier. And if, I think, I don't, again, Nathaniel, how much more valuable would a report from, say, a site that's directly and in the path of totality, would that transmit and or receive site produce more unique and more valuable information than would a site that is 400 kilometers off the path?
I think both are extremely valuable because what we're really trying to do is image the entire ionospheric picture. So you really need, it's kind of like if you took a picture of the eclipse, if you only have pixels that are right along the path of the eclipse, you don't have anything else.
Yeah.
That doesn't really give you sufficient context.
Yeah.
So I really think that all of the data is valuable.
Okay.
To really paint that full kind of geographic picture of
Okay.
what's going on.
Well, then I guess that then trying to weight receive sites based upon their geographic location doesn't sound like a useful idea. It's I mean, there will be plenty of receive sites. Just all of the Whisper Demon network will be reporting. It doesn't have to do anything to report. They'll be making their contributions. But there aren't reporters. I'd almost want to encourage people who are not near KFS or KPH or N6GN, which are sitting there reporting 24/7 on every band. We need people, I think, at other locations. So, in another thought is maybe we should just give people extra points from their distance, how far they are away from the nearest other receive or transmit site. I'm trying to encourage.
It's difficult, especially when you write articles in QST and other well-read media to try to encourage or drive people to one part of the. I mean, people live where they live.
Yeah, I know.
We do ask some people to go portable and operate from under the ellipse, and some of that stuff is all well and fine, but most people have a ham shack or home, and that's where they're going to be.
Yeah.
It's not field day so much.
Yeah. I had a Whisper receive site in Winnemucca, Nevada, which was right under the totality of the, but he isn't really a Whisper person. He's got tired of dealing with it, so he's sending me back his equipment. But that was my big disappointment of the last week, is to lose that site, basically to IP problems he has in his house. Okay. Well, I just threw those ideas out. I don't know what other.
I had a rather technical or pernickety question about the call sign restriction. So I think it was in section 4, above what you're showing now, and was it reporting under one call sign? Maybe was it section 3 then? I thought I saw something about needing a single. Each site will be scored under a single call sign, and a site being this 500-meter diameter circle. Now that's fine for users of Whisper Daemon, where Rob's software uses a single reporting call sign, but within the databases, it can cope with multiple individual receivers under that same call sign. So that's fine. But we know of some people that are not using Whisper Daemon that may have individual receivers, for example, on different antennas, and they routinely do use a different call sign and repeat using a receiver with a stroke A or stroke K is no problem. It's the transmitter with stroke A or stroke K that would be an issue. So how would you handle that of multiple receivers for those not using Whisper Daemon at the same site?
This may be something that only a Whisper user understands the problem. I think that the reporter would almost have to. Well, yeah. I mean, how do you, yeah? If somebody's reporting from multiple antennas at one site,
And
how
not
do we
using
how do
Whisper
we
Daemon.
yeah how do we aggregate them? Yeah.
I mean, if you take my earlier comment about the scoring thing being more or so difficult and so cumbersome, to back away from the concept of scoring, maybe this particular line really doesn't make sense any longer.
Yeah.
If we go to a more of a reporting, here's who did what, and even perhaps I said put a link in a downloadable format, so if somebody wants to see how they did, they can download the file and sort it and whatnot.
Yeah.
So Gwen, that's a good point. Maybe
yeah.
that line 3 doesn't need to be there.
No, it's it does need careful consideration, and why people do report using different call signs, those not using Whisper Daemon, is that the WhisperNet database can throw out duplicates. So somebody, for instance, that's has 2 receivers on 2 separate antennas with quite different patterns, that would be of real interest when you get the logbook for that site. We wouldn't want to throw them out under the scoring in line 3.
Yeah, I think
So I guess what I'm hearing is that there are established methods for identifying these separate transmit and receiver sites in the existing databases, and we certainly don't want to, nor could we want to change how that works today.
No.
And if those methods work and we can extract the data we need to do the science, then this line is kind of moot.
Yeah, it's almost, well, I know it's dangerous to try and edit in real time, but it's almost like each site will be scored under the designated or the submitted call sign brackets S, call sign Z. And so even KFS now, Rob has added KFS stroke G with slightly different hardware.
So I think what we would have to do is we could state that we would report and potentially rank the entrants based on the call signs and identifiers that appear in the various databases, because really that's all we have to go off of.
Yeah, no, that's good. Yep, that would solve it.
Okay, I'll make that change later. Great, thank you. So I guess I would like to give Steve plenty of time because he's into something a little bit new, but is it just in general agreement, is the group in agreement that we can kind of separate out the SEQP from the Whisper party from the TDOA, and each kind of have their own?
I think that's a very good idea. I think reporting, just to finish, I think you're right. Scoring on receivers is going to be, ranking on receivers is going to be very hard to do. If you wanted to, I think from my perspective, the hardest part of this is to get people to be transmitting. We'll have plenty of receive sites and receive data for sure. The harder part is to get how many can we get lots of transmitters along these paths, and I think that there it's easier to identify who's transmitting and give them a score based upon their presence, not how many people received them, but at least they were transmitting during that period. That for me would be extremely valuable, especially if they were transmitting FSD4W mode. But either Whisper or 4W, transmitters. I think if we could encourage them with giving them points, we could rank the transmitters. I think that would be something that would be good to encourage if possible.
Well, that helps me a lot as I'm thinking about what we would want to include in the articles for the amateur media, and encouraging more transmitters or people who are not transmitting today to get on the air. I think it sounds like it would be very useful. So
Yeah, I mean, if anybody who has a working FT8 system is a candidate as a whisper beacon. And
right.
all I have to do is switch the modes in JTX and go to that. And from my perspective, I think you get more information. Ham side would get more information from the whisper mode transmissions than they will get from the regular FT8 and FT4 kind of transmissions. Because
but I say tongue in cheek, you're biased, Rob.
clearly I am, and that's based upon my understanding of what information you would be valuable, and I know I'm not an expert on the science behind this, but my understanding is that the more receiver reports we get, especially from one transmission, with whisper mode, you could have 50 different receive sites receiving one beacon transmission in one cycle, and in the QSO mode, you're going to get one-on-one. So you're going to get 50 times more data from a beacon transmission. Correct me if I'm wrong about that, but it seems to me that would be a reason to encourage the whisper mode.
Okay, well, while we're thinking about modes and encouraging things, let me turn it over to Steve, because I know you've got some questions or some things to present to the group, and I want to leave time for that.
Yeah.
Okay, well, I don't have a lot of time. Can I share my screen here? Maybe I can. First thing on this business of how far away does the effects range? This was back from 2017. This was the path of totality. Here's WWV up here and WWVB. So the path of totality was completely north of WWV, and here I am down here in South Texas, and this path was completely south of the totality. And over here on the right is what I saw in WWVB at the bottom. This is a linear scale. When the Eclipse came by, its signal strength increased 10 dB, which I assume is due to the absorption and the delayer going down. It's got the same 10 dB at 5 megahertz. Point is that the effects of this eclipse are going to be far ranging. I think you'll see them coast to coast at some level. Well, that over to the, can everybody see this?
Your sharing went away. We had it for a minute, but
It went away. Okay,
we had your PowerPoint, but not any longer.
let's do it again. How about this one?
There we go. Yep, that's it.
Okay, well, the idea is, this is a path from Colorado to Texas, because I happen to have this data. So you got multiple modes possible if you're low enough in frequency to support the higher angles that the multiple hop modes need. So here's 1 hop, 2 hop, and 3 hops off of some height layer. And here is the time of flight in milliseconds for these different modes. Here's 1 hop mode over here, 2 hops, 4 hops or longer, of course, because of the extra up and down, and 3 hops. Now, it would be great if we could measure, 1 hop time of flight, but that would require both stations to be absolutely synchronized in time, which is very hard to do. You'd have to get synced up with GPS DO or something, and then you'd have to calibrate out the long delays through modern radios with DSP IFs. It's just too hard to do over a wide scale. But what you can do is look at a time difference of arrival, for example, between 1 and 2 hop modes. Up here, 300 kilometers, so here's the F layer up here. We can't measure this directly, but we can measure this difference. It's not as accurate, but that will more or less post you somewhere on this graph. If you're lucky enough to get 3 hops, you can get yet another one. So that's the idea, is to try and measure the time difference of arrival between 1 and 2 hops. And once you get that, you can go back. It goes without saying that as when the eclipse goes by, the ionization goes away, and we've seen that this virtual height gets higher, so all of the paths get longer. And then when the sunshine comes back, they all shorten up again. And we've seen this over and over. So that's the effect we're trying to go after, is to try and measure the change in ionization height when the eclipse happens. So a couple of ways to do that is with a really, really short pulse, like a 1-cycle pulse. I've got some pictures of that at the very end. We've done this timing with WWV's 5-cycle at 1 kilohertz pulse. Problem is the 5 cycles is too long. These time differences of arrival, you see at F layer height is on the order of a millisecond. This is 1 millisecond between 5 and 6. 1 millisecond, the pulse is 5 milliseconds long. So when you get these two, they come down on top of each other and superimpose. But you can also measure it with a chirp. A normal chirp radar is a sweeping carrier, but you know what? For the rates that we're after here, a audio chirp fed into the mic input of a transmitter will work. Here's a SPI simulation of 2 chirps. These are 100 kilohertz per second. So it's like 0 to 5 kilohertz in 50 milliseconds. And they're delayed by 1 millisecond. And when you sum 2 chirps with a time delay, which is what happens in your receiver, if you receive both a 1-hop and a 2-hop mode at the same time, they are going to sum in your receiver, and you will get this modulation on top of it. You'll get a beat note. And the beat note is the sweep rate times the time delay. And you can measure this period then and get back to what it was. On the left here is a 1 millisecond time delay. Here's a 2 millisecond time delay. And this does work. We've put these waveforms on WWV, and they've been transmitting, still are, at 8 minutes past the hour on WWV, and 48 minutes past the hour for WWVB. Listen to these things, record them on a wave file recording program. And here is one of those fast up chirps received from WWV. And this is commensurate with a 1 millisecond time difference of arrival, so it must be between the 1 and 2 hop modes, which is about right for Colorado to hear. So we do have some on-air stuff. If you want to practice with these things, they're still transmitting those waveforms. So to look into this a little bit further to see if I needed to modify this waveform some, and I believe I do, I took those chirps and I put them into the 2 stereo channels of a wave capture program. And then I could introduce different time delays between the 2. I also reduced the amplitude of 1 by 3 dB so that the interference didn't go all the way to 0, didn't get complete extinguishment, which are not likely to get anyway. It's not likely that the things will be exactly the same amplitude. And then sum these together into a separate computer to record the difference. And so here's how they summed with a 125 microsecond, 0.125, well, let me back up. Oh, yeah, 0.125 millisecond delay. Would I be happy with this? Not really. I've only got 1 null here and a peak here. That really wouldn't be very good for making a good measurement. And I would like to go down to 100 microseconds because I've seen some things that were that close coming from WWVB. I don't know what they are. Maybe it's XO mode splitting. Well, I don't know what they are, speculating. But I'd like to be able to see that far. And to do that, I'm going to need a faster sweep rate. So I'm thinking now, instead of 1 chirp, I need maybe several of them with different sweep rates. Here's what you get for a 1/4 of a millisecond time delay. I've got 1 null here coming up to a peak here. You could almost use that. Here's a 1/2 a millisecond. This is measurable from here to here or from here to here. Here's a full millisecond. This is what we saw before. This is a millisecond gives you a 100 hertz frequency beat when you're sweeping at 100 kilohertz per second. Here's 2 milliseconds, starting to get a little closer together. And here's 4 milliseconds, starting to get really close for comfort. You know, where do I tell where these bottoms are, where the tops are? Really a Fourier transform or a D-chirp function in MATLAB might be better, but still it'd be good to be able to read these directly. So for this end, for the longer delays, I'd like to go to 4 milliseconds. I'm going to need a slower chirp rate. So I'm thinking that I'm probably going to take multiple chirps and just concatenate them together or space them apart. Back on the short pulses, again, WWV was transmitting 5 cycles of 1 kilohertz. This is what 1 cycle of 1 kilohertz looks like, and WWV is transmitting these every hour now. And here is a copy where we indeed received 2 of those. And this wave program gives you a nice time scale on the bottom. And these are separated by 1.3 milliseconds, which is, you go back to that very first side that predicts based on this simple geometry what the differences are. 1.3 milliseconds would put you about right here, which is about 330 kilometers height for the F layer. It's pretty good. The smaller delays, how about multiple hops off the E layer? E layer is down here at 100 kilometers height. And indeed, the time difference of arrival between 1 and 2 hops off of the E layer is only on the order of 100 microseconds. So I'd like to cover a wider range. When I'm all done, I would probably send a waveform something like this, maybe a string of these short pulses, followed by the chirps, followed by another string of pulses, and then maybe a Morse code identifier. And what that would sound like would be this.
Kind of jazzy.
So exactly how we do this, certainly not everybody is going to be transmitting these, and to encourage more people to receive them and copy them either by 2 guys talking to each other or just beacons on a scheduled time slot, that's still to be determined. Gary and I have been talking about exactly how we would do that, but this is basically what we would be transmitting. It would take about that long. And we should do it at least 5-6 times an hour, really, if we want to profile it. I've been thinking about what the effects of a frequency error might be if we use sideband, because this is, after all, a frequency-based measurement. And if the two radios, 2 sideband radios aren't 0 beat with each other, then you're going to have a constant frequency offset, and that's going to affect this data. I need to do an honest analysis to find out what would say, certainly 2 radios of modern design would be within 100 hertz of each other. I'd have to look and see how bad that hurts us. The fallback is to use AM, which doesn't really care if you're off frequency a little bit, because you're looking at the sidebands off the carrier, and they don't care about slight frequency errors. So anyway, that's where I am. This morning on the case Telecon, I was solicited some help with the MATLAB generation of these chirps, so I can try some different sizes. The ones you heard, I took the chirps that we initially started with, they're on WWV, and I took them and turned them around and spliced them together with this wave file, but I don't think I got them aligned to start and stop precisely enough, so I'd rather have that done with mathematical precision. But that's where I am. The output will be a estimate of how the ionization layer heights are changing over the course of the eclipse.
Really good update, Steve. Go ahead, Rob.
I'm sorry, I can't hear you.
I was going to ask what part of the band you would transmit on.
Well, if we do AM, we would probably pick one of the AM frequencies like 3880 on 80 meters, or
Yeah.
7290 or 7160 on 40. And we want to emphasize the lower frequency bands. And the reason is, the higher you go up in frequency, the harder it is to transmit the very high angles of propagation required to get multiple modes. For example, 3 years ago, when I started doing this, I almost never, ever, ever saw 2 modes off of 10 megahertz WWV. Now I can see them almost every day, but we're a lot farther up on this sunspot cycle than we were. We didn't have a sunspot cycle 3 years ago. It's flat. So I'm thinking 160, 80, 40 are going to be the ones of interest, although we probably should try some on 20. 20 may be hard to get 2 hops. And it all depends on how far apart the stations are, right? The closer they are together, the higher still the angle has to be to get that second hop coming in. And if we don't have 1 and 2 hops, we don't have a measurement.
Do we need to write something into the SCQP rules to clear some frequency space for you to be able to do this, so that the contesters don't trounce on you?
It might be a good idea.
Rules Gary's writing? Yeah, I guess you could. You could
I mean,
establish some protected frequencies.
Yeah, since we're able to write the rules for the SCQP, we can build some frequency coordination and management right into it.
We could. And we could schedule these things. You know, I would anticipate soliciting a group of people willing to transmit these waveforms,
Mhm.
and then actually assign time slots,
Mhm.
or maybe even rotate, so that we've got multiple of these stations spread around the country.
Yeah,
And if we could publish a schedule, like on this particular time, listen on this particular frequency.
it would be
This
good
be-
too. It'd be good too if we had some sort of hypothesis or real scientific question that we were, trying to answer with this particular technique. That might help us to figure out where we want to get stations located, and exactly how often you want to have them communicate with each other.
Right.
So I think
Would this
when we
be would this be considered digital mode, or are you going to be doing this in sideband portion?
I think we do it in the, we wouldn't do it in the, well, that's a good question. It's probably closer to slow scan TV than it is anything else. It's not digital because there's no information being transmitted other than your call sign and Morse
Right,
code.
but I mean, in terms of band plan, where
Yeah.
does this actually fit? Of course, are you going to be announcing it by voice?
Yes,
So maybe it is in sideband.
but if we would have less interference issue, it may make sense to go in that very high part of the digital band, just under where the phone band starts. That's usually a wasteland anyway.
Yeah, the very upper end of the phone band.
No, the very upper end of the digital and
Well,
CW band. before
Here's
the phone
another
band.
idea. If you're doing it in sideband, do it in the extra portion.
Yes. That's a good point.
In terms of science questions, I think the way I wrote it into the proposal was I said that we were going to use this as a method of measuring the changes in the bottom side height of the ionosphere. And then we were going to compare that with, validate it with ionosondes. That's what I wrote.
It sounds exactly right.
Yeah.
Did I not come across as saying just about?
Oh,
that?
no, you did that exactly. That's exactly what I thought. I'm just trying to think, is there anything else in terms of like Eclipse specific science that we're trying to do? Gareth, do you have any thoughts, or do you think?
I mean, we didn't explicitly write it in the proposal, but one of the things came to mind was strategy, the presence or excitation, I guess, of strategy during an eclipse.
Mhm.
Because I know with Magda Moses's work, she was he was looking at Superman data, and I think Bharat Kanduri was telling me that they saw sporadic E, and that was talked about by other people as well. And I'm wondering if this is a technique we can use to sniff out the presence of sporadic E or something like that during the eclipse.
Yeah, you would be able to identify sporadic E with this, right, Steve? Or E
You have
region.
to happen to time it right. Or if we're on often enough, we might catch it.
Mhm.
Because it show up, if you'd had been using the F layer and suddenly a sporadic E cloud moves across the path and you suddenly cut your propagation delay time in half.
Mhm.
Yeah, you'd identify it.
Yeah, so if you're very systematic with how you're making these soundings, you might be able to see that might be something you could look for.
It is.
Yeah, because the rest of the SCQP is a very kind of random sort of event, but what you're doing has the potential to be much more strategic and planned.
And maybe, do you think TIDs could be, is it a resolved enough technique to, I don't know what a TID would look like going through one, appearing in that.
The TIDs are going to be a little trickier with this
Yeah.
particular technique because the TIDs, they generally have periods between like 15 and 60 minutes, right? So
Yeah.
if you're just doing a sounding that just lasts a couple of seconds and you only do it, a
Every
few
8
times
minutes,
an
is it?
hour, you're going to have a
Oh.
really hard time sensing a TID with this sort of
Yeah,
sample.
that's right. Yeah, you're right. Yeah, I forgot they're only like, is it on the 8 minute or on the 8 and 38 or something like that?
Well, no, here Steve has the ability. Steve is actually transmitting here, so he's not using WWV. So
Oh, okay.
what Steve is proposing is that the hams actually transmit. So we actually can increase the sampling rate here. And we have a little bit more control over it, provided people are, you have a person sitting at the radio pressing a button saying, play this thing now. And then you have someone on the other side with a data recorder saying, record this thing now, but so it's not fully automated like the WWV capture is, but we do have the ability to transmit multiple times per hour or things like that.
That's a good point, and I didn't emphasize it enough. These waveforms are going to be transmitted by hams.
Yeah. So
No
I
other-
kind of think with your project, Steve, one of the reasons I really want to talk about more what science questions we might answer with your technique is because we really do have a chance to plan it out a little bit better. And if we really flesh out the idea of what we're looking for, besides, and yes, we will do the whole height thing, but if there's anything else that we're interested in, now's kind of our chance to figure out how to do that.
I agree.
Yeah. Which I think we're not too far away from that. I think we're not far away.
By the way, on the WWV thing, I recorded both every transmission they had one morning along with recording their Doppler.
Mhm.
And found out that once an hour is woefully inadequate.
Right.
I mean, the morning Doppler swings, I got one of their data points at 8 minutes after 1 hour. And then the
Mhm.
entire Doppler swing happened. And at the very end of it, I got another data point. So I missed everything in between.
And that's what I was saying. I really don't think you're going to see TIDs with what you're doing,
No.
because even if you are sampling more than once an hour, you're probably sampling at best every 5 minutes, which is still sufficient to see a TID, but it's still more difficult than, say, some other techniques.
Well, we could think about an automated, much faster repetition rate experiment, I didn't think about proposing because I thought it'd be too obnoxious.
Well, we can keep discussing that.
Yeah.
Yeah, we can kind of we can keep discussing that. Whatever we choose for this, we really do want it to be in the spirit of something that you know, hams can do without being obnoxious.
Yeah.
Because the world, there are automated ionosons, there are automated super darn radars out there. So there's a number of automated radio instruments out there. So we want to do something that, you know, is both useful and, you know, is really within the amateur radio spirit of being cooperative and pleasant and all of that sort of thing.
On the other
I
hand,
take
it's
it
only
you
gonna
won't be
last for a
doing
few
it on
hours.
75 meters then?
It's only gonna be for a few hours.
That's true too. So I mean, there's a balance. So yeah. So I think we should, maybe next week we can continue discussing it. We're at the top of our hour now. So let me just bring up the notes here. See if I wrote some notes down already. Try and capture.
Just to point out, on 75 meters, I think you're supposed to be obnoxious.
Oh yeah. So and that's good because that's one of the bands we want to do this on the lower bands. So that might work out well.
Yeah, it's not gonna be like you're gonna get a lot of DX and 80 meters in the middle of the day, so.
True. Yeah, and it's gonna be fairly, even within the band, we're gonna be trying to keep that, you know, within one particular frequency segment. We're not gonna be dominating everything with this. So all right, so I already wrote back here that Gary AFAA got feedback from Becky at the ARRL saying that the ARRL can publicize the SCQP again, both in QST and on the Air magazine. There is a July 2023 deadline for materials. We will need to stay in touch with Becky to make sure we are on track. Rich Moses in W2VU also said CQ would publicize this. We also need to stay in touch with Rich as to make sure we are reading publication schedules and requirements. Okay, Gary thinks we should break the Whisper party rules out into a separate webpage for the SCQP. He also notes that FT8 Whisper only supports 4-character grid scores, not 6. Nathaniel notes that having people exchange the exact location over the air is less important, so long as people report their station location accurately when submitting logs. There was an extended discussion regarding how important it is to have people transmitting right under the Eclipse. Nathaniel notes that we actually need measurements from all over the US in order to image the bottom side ionosphere. Steve Serwin notes that Steve Serwin showed evidence from the 2017 eclipse that even if you are well south of the eclipse path, you will see eclipse effects. Bob Gerzoff notes that you need to have control path control data in addition to Eclipse data. So it is also, which is another argument for not having everyone right under the Eclipse path. Steve Serwin, WA5FRF, gave an update on his TDOA experiment planning. He did an analysis of the chirps currently used in the Hamsci WWV broadcast experiment, and found that those chirps were too fast to accurately measure the delays that he observes. Am I saying that correctly?
Actually, what we picked for them was just about perfect, because I set it up that way when I picked that frequency for the distance of WWV down to here. But when we spread this out with multiple stations, we need to cover a wider range.
Okay.
So we'd like to expand the range of delays that we've seen on both ends, because we're going to have stations spread all over the place instead of just from Texas to Colorado. So I just like more variety.
Okay, so he did analysis of the chirps currently used for the and noted that they were designed to be optimal for the WWV WA5FRF path. For the SEQP experiment, we need more variety in chirp rates, because we will be
We'll have greater geographic coverage.
a larger variety of path lengths and locations during the eclipses. How is that?
Perfect.
Great. Nathaniel notes that we should spend some more time thinking about the exact, or about the best scientific objective for the TDOA experiment that we can best plan, so that we can have the most optimal plan for running the experiment. Currently, the objective of the TDOA experiment is to examine changes in the bottom side ionosphere height as a function of time, and bottom side ionospheric height due to the eclipse as a function of time. This will be validated using ionosonde data. We will continue to discuss this at the next meeting. How's that?
Good by me.
All right. I think that's good for today then. Thank you so much, everybody.
Yeah, thanks for everyone's input.
Thanks, everybody.
Have a great week and I'll talk to you soon.
Have a good week.
Bye.
Bye.
Right, thank you.
Bye.
73.
73.